Welcome to the second System of Inequalities video. In this video, I'm going to be going through an example, step by step, of how to solve a system of inequalities using graphing. Here's my system of inequalities. Remember, that's two or more inequalities that you're solving at the same time. And looking at the system, I'm pretty happy. I notice that y is already isolated, which means I'm in slope-intercept form. And that's my first step. And I'm going to try to keep writing these steps over in this area. So take a moment to write this down into your notes. It is going to have to go away to make room for new steps. So put into slope-intercept form, I'm going to make a note to myself that means isolate y. And I'm happy because I don't have to do that for this particular system of system of inequalities. So that's one less step that I need to do. My second step is to graph both inequalities. And I'm going to graph those using the same steps that I would graph a single inequality. So all the rules that we've talked about for the last 2 days still apply. I still need to use a dashed line when there's no or equals to symbol. I still need to use the y-intercept and the slope to graph. But instead of graphing one inequality, I'm going to graph two. If you haven't written down this step yet, do it quickly because it's about to go away. So looking at my inequalities, I see that I have a y-intercept of 1. So I'll mark that point. I'll go up to 1 on my y-axis. My first inequality has a slope of 2, which means that I'll go up 2 into the right 1 to find my next point. Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and I'll continue that until I have this inequality plotted. So there's the first inequality. You'll notice I use that dashed line because I don't have an or equals to symbol in my inequality. Now I'm going to move on to graphing the second inequality. Again, it has the same y-intercept, but this time a slope of -2. Which means from my y-intercept of 1, I'm going to go down 2 into the right 1, down 2 to the right 1, down 2 to the right 1. And if I wanted to go in the opposite direction, if I wanted to go to the left, I would need to go up 2 to the left 1. And notice I'm flipping both the y direction and the x direction to get these points on this side. So we're done with step 2. Both inequalities have been graphed. I followed all my rules for graphing inequalities. So now we're ready to move on to step 3, which is test each region. For a solution. And now the regions, here's one region, here's another region, here's another region. You can see they're outlined by the boundary lines of the inequality. So I have 4 regions to test. Now there's a lot of different possibilities in these regions of points I could test. I could test that point, or that point, or that point, or that point, or that point. But I want to make a smart decision. I want to choose a point that is going to be easy for me to test. And those are going to be points on the axes. And the reason why that would be an easier point is because x or y will equal 0. So let's make a note. Test on an axis. It's easier. Now you're thinking, okay, I got a test. Which equation am I supposed to use? Which inequality should you use? You have 2 of them. Which one? Well, it goes back to our definition for a system of inequalities, where both inequalities are solved simultaneously. So you have to test both inequalities, and they both need to be true at the same time in order for the point to be a solution. So let's make another note. Both inequalities must be true. If you haven't copied down this third step yet, do so now because it's about to go away. So I need to test a point. I'm going to test one on an axis to make testing it a little bit easier. I'll test the point 0, -2. That means 0 is my x value, 2 is my y value. And I'll substitute those into both inequalities. So I'll end up, my y value is -2. It's less than 2 times 0 plus 1. -2 is less than 1. And that's great. That works for that inequality. But I'm not done yet. I have to test my other inequality. So I'll substitute the same point into the second inequality. Again, y is -2 greater than -2 times 0 plus 1. Well, -2 times 0 is 0 plus 1 is 1. So I have -2 is greater than 1. -2 is definitely not greater than 1. So that means that this region cannot be a solution, because both inequalities have to be true at the same time, and our second inequality wasn't true. So we need to pick a new point to test. And again, we're going to want to pick a point on one of the axes. And I'm going to test the point right here. And that point is 2, 0. My x value is 2. My y value is 0. And I'll plug in those values to my inequalities just like I did before. And I have 0 is less than 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So I have 0 is less than 5, which is true. Awesome. Works for our first inequality. Now we got to substitute in the second one. They have to be true at the same time. So 0 is greater than -2 times 2 plus 1. Well, -2 times 2 is -4 plus 1. I end up with 0 is greater than -3. And 0 is greater than -3. So my second inequality works. What that means is that this whole region is a solution. So to finish the problem, I need to shade this entire region. So I've shaded the entire region. That means any point that I pick in that region is a solution to the system of inequalities. I hope that this video helps you get an understanding of systems of inequalities. You have one more video to watch. I'm going to do another example, but I'm going to go through it a little bit quicker. Just another chance for you to see how to do systems of inequalities.